Hello everyone, my name is Caceres and I'm part of the Security Evaluation of Encrypted Databases project, or SEED for short. The other member of my team is Joanier Pinales, and our product owners are Mark Finlayson and Rob Cunningham. This is going to be a walkthrough of user story number 688, which is the user story that filters out fake data from the results set. This user story was created and approved during the sprint planning meeting with the product owner. The acceptance criteria as well as the requirement elicitation were also approved at that time. The description of this user story is that, as a user, I would like the result set of my queries to be free of any fake data so that there is no cause for confusion. There are two acceptance criteria that must be met for this user story. This feature must delete rows of fake data from the result set before reaching the user and maintain the randomized encryption level of the fake column. These are the requirement elicitations that were derived from the acceptance criteria. In order to return a result set without fake data in it, we would need to delete those rows that contain fake data from the result set before it reaches the client. The other acceptance criteria was to maintain the randomized encryption layer of the fake column. In order to accomplish this, we would need to parse and filter the result set outside of the database to remove any risk of stripping that layer. The use case diagram for this feature is going to include a user who is going to interact with the MySQL client, typically by submitting the queries he wants. The client is going to interact with the proxy, which will be important later on in this setup. And finally, we get to the database that gives us the result set of the user's query. Since we have to filter before getting to the client and also have to parse the result set outside of the database, we're going to go ahead and include our parsing and filtering here in the proxy itself. Now that we've done our requirement elicitation and use case diagram, we're going to move on to analyzing the system and trying to see where we could implement this feature. So we'll navigate to our code base, and we kind of have an idea already of where to look. We want to look into our proxy code and see what's going on in there. We have a makefile, a readme, a connect to wrapper CC file, which is going to connect our wrapper to the proxy, and the proxy wrapper itself. Let's take a look inside of the wrapper. So this is the custom code by my team member Joanier, which handles frequency tracking. We can see a function that gets the proxy connection, as well as another function to disconnect. This function here reads the query and makes a call to a function called readQueryReal. Let's see if we can find that. It looks like this function does some checks on the query and actually is where the query gets rewritten by cryptdb. If there is an error, it seems to generate an error message in proxy.response and sends it back with proxy.sendResult. That looks like a promising call. If it does an error, then we make a call to next handler. Let's take a look at that function. Okay, so right off the bat, we see that next handler seems to handle the rows and fields. It also adjusts the proxy's query queue, and down here it handles the result set. And it looks like this is where the result set is sent back to the client by the proxy. So here's where it seems like I would add the code for my feature. Now that we have some idea of where to implement our feature, let's take a look at the sequence diagram. To keep the video short, I had already completed it beforehand. So the user interacts with the client by submitting a query. The proxy intercepts the query before it reaches the database, then rewrites it to match the encryption of that database. We're skimming over this encryption process because our feature revolves around the result set rather than the query. Once the database passes the result set to the proxy, it unencrypts it and prepares to send it back to the client. Since we can't filter an encrypted data set, here's where we're going to put our code, where the result set is in plain text. Once we've filtered out the fake data rows from the result set, we're then able to pass it back to the client to display to the user. We already briefly saw the code I had written, but here it is. After the result set has been unencrypted and the result set is being generated in proxy.response, we look through the field list for the fake column and grab its index. Once the index of the fake field is found, we then loop through the rows looking at that field and put the index of the rows that have the fake column equal to 1 in the deletion list. We then iterate through the deletion list and remove the rows of those indexes, being careful to account for the offset created when the row list adjusts to fill the removed indexes. The result set is now filtered from any fake data, and the proxy then sends it to the client. Here's the feature document that has the image of the unit test, where you can see that the server holds various rows of fake data. This window shows the server side of the system. The second picture is the client window. As you can see, none of the rows with fake equal 1 are displayed to the user. After we finish testing the feature in the system, we demo the feature to the product owner and get their approval. With their approval of the feature and making sure that it meets all the requirements, we commit the changes to GitHub and submit a pull request. Thank you for your time. That was the walkthrough of user story number 688.